the angle between those vectors? Okay, so it's giving you all the steps. Now what I might do instead would be, here's the setup, what's the angle between the vectors? Okay? So I'm not telling you that you need to turn it into IJ components. I'm not telling you that you need to take the cross product. You are going to have to do those things. You see my point here? In the homework, it's laying out step by step how to get from the beginning to the end. I would be much more likely, this is a strong hint of things to come, to give you the setup and then just ask for the last one. And so, because that way I get to test you on, do you know what steps you need to take to get from beginning to end? Whereas in the homework, if I tell you all the steps, I'm not getting to test you on that part. I'm getting to test you on whether or not you can carry out each step, but I'm not testing you on whether or not on your ability to figure out the steps you need to take. Do you understand that one? Okay. I also do have a great fondness for red herrings. Okay, when you think about my ski lift problem and chemical projects where I gave you a bunch of weights and stuff that didn't actually matter. And so you need to know that they didn't matter and discard them. So bear all that in mind. I did put this thing on Moodle or email it to you or whatever. This is the exam topics thing I did on Monday. So hopefully everybody saw this. No?
How's that?
Well, I put it on Moodle and I emailed it. I sent an email. Anyway, it's on Moodle. So this basically lays it out what you are responsible for. And you do get an equation sheet, 8.5 by 11 both sides. No worked out problems, and I'm going to want to hand it in at the end of the test. Okay, I'm not giving you any equations. I will give you conversion factors if you need them. For the most part, like I said, the exceptions that occur to me are, I'm not going to tell you how to go from degrees to radians, and I'm going to expect you to know what gravity is. Either 9.81 meters per second or 32.2 feet per second. So you know those ones. Alright? Slug stream come up. Although, if they did, I probably would give it to you in this class. I would give it to you in this class. We haven't really gone through slugs. Okay, so any questions on the test? Before I move on?
The problems are going to resemble the homework.
That's what I said before. Kind of, yeah, sort of. In a sense, yes, but I'm not. So in the homework, like I was saying, I laid out, do this step, then do this step, then do that step, then do that step. I'm going to kind of not do that part.
They actually make the actual problems a lot harder though?
No, but it probably will seem harder. It won't be harder than the problems I've done in lecture. Probably the general lead problem ended up being a little bit simpler than most of the problems I did in lecture. Okay? In terms of like the vector addition stuff. I would say it was simpler than throwing the football from the pickup. And it was simpler than the boat and the current. I would expect more level of difficulty of those ones lecture problems. That's the level of difficulty I'm aiming for. Is the lecture problem. Well, if I were you, I would go through here. Here it says the Sean's all of chapter 1 and the problems in chapter 2 using rectangular components are good practice in video game. Yeah. What's that? Potentially. So yeah, if you look at that stuff, that I would say would be good practice. Sorry?
Go over the homework.
Yeah, when I posted my homework solutions, you can go over that. is conserved, meaning that in a closed system, not affected by external forces, its total linear momentum cannot change. Okay? So if you have some system and there aren't other things coming in and affecting it, you don't like, some other things that affect some force or coming in here and hitting something, you just have some closed system, okay? Total linear momentum can't change. Momentum is conserved. Right? It's not going to change. Now it's a vector quantity, so you have to bear that in mind, and we're going to have some also PowerPoint examples here and all that. But so it's conserved total system value for the linear momentum cannot change. Everybody understand what I'm talking about here? Hopefully. You guys should have all had this in physics. Okay. So it's a vector quantity. So we have the momentum P equals mass times velocity vector. And then if we have multiple things, like so for a system, and say that the total, so P total, the momentum total equals momentum of all the various components added up, however many you've got. Alright? And so it's also the same thing as saying the momentum total equals mass 1 V1 plus mass 2 V2 plus however many you've got. Again, these are vectors. Okay? So direction matters. Direction matters. V1 and V2 and so on. A change in momentum. So I'm using this. You're familiar with this notation for a change, don't you? So a change in momentum equals a variety of things, but force, and this is force as a vector, times change in time, how much time you've got. So you apply a force for a certain amount of time, and that will change your momentum.